Good afternoon, everybody. Can you hear me okay at the back? The microphone's okay? Yep. Louder? Yep, okay. All right. Okay. So thank you for coming to the presentation. I'd like to talk a little bit today about 3D print electronics and what we're also doing a little bit touch on the issue of scalability there for volume applications. So my agenda is as follows. One slide in the company overview. They'll talk a little about what 3D printed electronics is. I know a lot of you know about it already, that you're experts. But I'll just cover on a couple of points. I'll talk about the different processes and I'll show some application examples and then talk about where we're going in the future, what we're going to do there. Will you give me like a little bit of a note 2 minutes before the end if I talk too much? All right. Thank you. Good. So Neotech, so we're a machine tool manufacturer. We're based in Nuremberg in the south of Germany. We're specialised on 3D printed electronics, so that's basically what we do. We build machine tools for this purpose. We've been around for quite a number of years. We've been pioneering this work. We built our first system in 2010. We've had some volume production, limited volume production in cell phones in Asia in the period 2012-2015, and we're active across a wide variety of industries. So first question, what is 3D printed electronics? So really we're defining this as the way of adding printed electronics functionality, sometimes in combination or more often now in combination with classical surface mount devices onto and also into mechanical structures. So we have two basic processing routes here. So we have sort of the classic MID route here on the left-hand side where we've got an injection molded part, we print the circuitry, you place your SMD components to make your mechatronic device. And then more recently, since about 2016, we've also been combining classical 3D printing, so building a mechanical structure and integrating the electronics, then not just on the surface, but also inside. You can see an example here on the right-hand side. This is the classic egg timer that was produced by the University of Erlangen and Nuremberg FAPS Institute. And this is an X-ray image, and you can see quite clearly we've got a mechanical body that we've built. So we start with a base plate and we build up, and then during the build we put electronic components in, we print the circuitry. There's something like 6 meters of circuitry, I think, or 2 or 6 meters, one of the other. We've got LEDs on the outside there. So I'll show a couple of examples later of both processing routes. So the question is, well, why bother? You know, why do you want to actually make 3D printed electronics? Well, there are three main headlines here. The first is the design flexibility. The fact that you're going away from 2D into 3D, it gives you various benefits. You get higher integration of the products. You've got potential on, miniaturization, the whole flexibility of the shape. You've got the benefits of adding new functionality. So making dumb mechanical structures smart, adding intelligence, communication capabilities, and so on and so forth. Then the economic side. The economic benefits, again, this is an emerging technology. We don't compete directly with classical PCB manufacture. Your benefits really come from another of the sources if you look at the economic side. So it's the reduced part count. So you haven't got a PCB anymore. You integrate it directly into your mechanical housing. You've got shorter process chains. You're reducing the number of materials. You're reducing the materials mix. You're going also potentially to a high level of automation, and there's also in some cases looking at increased reliability. You're getting the human factor out of the process, which again comes back and gives you a little bit of benefit economically. And then really the big one, I think, or a very important point and with growing importance, is obviously the environmental side. So reducing the materials mix. So the number of materials used in the systems is reduced quite massively. You're getting rid of the PCB, all the materials in there. You're simplifying the mix of those materials. The actual quantities you use because you're working additively. You're not relying so much on subtractive techniques. And more localized production also can give you some benefits under the environmental headline. So what does actually a machine tool look like if you want to do 3D printed electronics? So what we do, we start off with a base platform. We generally work with 5-axis CNC type motion. We have built our first system, was actually a 6-axis CNC, 6-axis robot system, but we're fixed now on 5-axis motion. We have backing that up with a CAD/CAM software that allows you to design your process route. You can design and build your parts in that. Also, so you've got that as a baseline, and then you select the tools that you want for your particular application. So we use a variety of different printing tools, because what you'll see is that no one printing tool will actually do everything that you want it to do. So we have, piezo